Hello guys, let's learn how to name alkenes according to IUPAC nomenclature. Alkenes are unsaturated hydrocarbons that are characterized by the presence of carbon-carbon double bond. The general formula by which we can represent alkenes is CnH2n. Just like alkanes, we would use prefixes for the number of carbon atoms in the longest possible chain. But now the name would end with ene rather than ane as we had seen in alkanes. So let's see what are the IUPAC rules for naming alkenes. The basic rule is the same. First, you have to select the longest possible chain that contains the carbon-carbon double bond. Then you have to identify the number and the types of substituents that are present in the molecule. The third rule is to number the carbon atoms in the chain. So in this case, because we have a carbon-carbon double bond and it has a higher priority than any of the substituents present in the chain, so we have to start numbering of the chain from a carbon atom so as to give lowest possible position to the carbon-carbon double bond. But a situation may arise in which the double bond may occur at the same position from both sides, that is, from the left or from the right, the double bond occurs at the same position. Then you have to number the carbon atoms in the chain so as to give the substituents the lowest possible position. So carbon-carbon double bond has a higher priority than the substituents. First, you have to take into account the position of the double bond, but if it is the same from both left and right hand side, then you have to take into account the position of the substituents and you start numbering from an end so that the substituents get the lowest position. And then you have to mention the position of the double bond, of course, while writing the name of the compound. And finally, you name the molecule as follows. So, as we have seen earlier, how to name a molecule according to IUPAC nomenclature, the name ends with the parent name or the parent functional group. Anything that has a lower priority is mentioned first while writing the name. So substituents, they have the least priority in any of the cases. So first you have to mention the position and names of all the substituents. Then you write the prefix for the number of carbon atoms in the longest chain. This time it should contain the carbon-carbon double bond. And then you mention the position of the double bond. And finally, end the name with E-N-E. Let's see some examples of alkenes. Here we have a very simple example, and you can see we have a single chain here having 1, 2, 3, 4 carbon atoms, and you know that for a 4 carbon alkane we use the prefix but. This is not an alkane, it's an alkene because we have a carbon-carbon double bond, but again the prefix but will be used, but because we have a carbon-carbon double bond and this molecule belongs to the alkene class, the name will end with E-N-E, so it's a butene. But you have to mention the position of the double bond while writing the name of the alkene. So for that, you need to number the carbon atoms in the chain and you have to start numbering from an end so as to give lowest possible position to the double bond. So if you start from the right, the double bond is at carbon number 1, and if you start from the left, the double bond is at carbon number 3. One thing that needs to be mentioned here is that this carbon-carbon double bond obviously involves 2 carbon atoms. So what would be the actual position of the carbon-carbon double bond? So in any case, these 2 carbon atoms, the sp2 hybridized carbon atoms, will have a lower number and a higher number. So like for example, if you start from the right, this carbon has a position that is 1, and the second sp2 is the carbon number 2. So in this case, we have to write the lower number as the actual position of the double bond. So if it is between 1 and 2, the position will be 1. If it is between 3 and 4, then the position would be 3. So from the right hand side, the position of the double bond is 1, and from left hand side, the position is 3. Because it is closer from the right hand side, we start numbering from the right in such a way so as to give lowest possible position to the double bond, and so it is 1 but, and the name ends with ene, so it is 1 butene, or you can write it in this form as well, but hyphen 1 hyphen and then end the name with ene. Let's see another example. This is a branched molecule. We have two chains possible which have the carbon-carbon double bond, and you can count the number of carbon atoms: 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So both the chains have 5 carbon atoms and 1 substituent. So it's up to you. You can select any of the two chains. So we select this straight chain with a methyl substituent here and a carbon-carbon double bond here. As we have mentioned before, that the double bond has a higher priority than the substituent, so you have to start numbering from a side so as to give lowest possible position to the double bond. So in this case, again, we start from the left, giving position 1 to the carbon-carbon double bond, and as a result, this CH3 group or the methyl group falls at position 4. So while writing the name, you have to first mention the position of substituents and the name of the substituent. So it's a 4-methyl 1-pentene, because we have 5 carbons, so it's a pentene. Or you can write it in this form, 4-methyl pent 1-ene. Here we have another example, and now you can see that the double bond in the chain is at the same position from both ends. So you start from here, 1, 2, 3. The double bond is at carbon number 3. And if you start from here, 1, 2, 3, the double bond again falls at position 3. So now from both ends, the double bond has the same position. So if the double bond cannot decide from where you should start numbering, then you have to look at the position of substituents. So from here, the substituent, the methyl group, is at 2, and from here, the substituent is at 5. So we have to start numbering from the left so as to give lowest position to the substituents. So it's a 2-methyl 3-hexene. We have 6 carbon atoms, so it's a hexene, and at position 3, we have the double bond. So we mention the position of the double bond here, then hex for the 6 carbons is the chain, and end the name with ene because it belongs to alkene. So it's a 2-methyl 3-hexene or 2-methyl hex 3-ene. Make sure you know where to put the hyphen and where not to put it. Now we have another example here, and we have several chains possible, but the longest is this one: 1, 2, 3, 4, 5, 6, 7 carbons in the chain with 3 substituents and a double bond. And if you count the number of carbon atoms from the left and the right, or the position of the double bond, so from the right, the double bond is at 3, and from the left, the double bond is at 4. So you don't need to see the positions of the substituents, because now the double bond can decide from where you should start numbering, and obviously you have to start from the right hand side so as to give lower position to this double bond, which is at 3 from the right hand side. And then we have 3 substituents. So first you have to mention the positions of all the substituents, and the name is methyl substituent 3 times. So it's a trimethyl at position 3, 5, and 6. So it's a 3, 5, 6 trimethyl, and at position 3 we have the double bond. So you write 3 here. We have 7 carbons in the chain. It's a hept and it belongs to alkene, so the name ends with a ene. So it's a 3,5,6 trimethyl 3-heptene, or you can write it as 3,5,6 trimethyl hept 3-ene. Here we have an interesting example, and you can select the longest chain, 1, 2, 3, 4, 5, 6 carbons in this chain, 1, 2, 3, 4, 5, 6 carbons in this chain. Both the chains have two substituents and a double bond, so you can select any of the two chains that are the longest. So if you select this straight chain and then you count the number of carbon atoms or the position of the double bond from the left and right hand side, you see that from left the double bond is at 3 and from right the double bond again is at 3. So double bond cannot decide from where we should start the numbering. Then obviously you have to see the positions of the substituents. We have two substituents, a methyl group at this carbon and an ethyl group at this carbon. So if you start from the left, the substituents are at 3 and 4, and if you start from the right, again the substituents are at 3 and 4. So again, substituents cannot even decide from where you should start numbering. But interestingly, we have two different substituents. We have an ethyl group here and a methyl group here. If both the substituents were similar, then it was your choice from where you want to start the numbering. But here we have two different substituents. An ethyl group is here and a methyl group is here. So now you have to take the alphabetical order into account while numbering the carbon atoms in the chain. So ethyl comes first in alphabetical order. So you start from an end so as to give ethyl group the lowest position. So we have to start from the right so as to give it the lowest position. So it's a 3-ethyl. Again, while writing the name, you have to write it in alphabetical order. So you mention ethyl first, which is at 3 from the right, and methyl group is at 4 from the right, and at position 3 we have the double bond. We have 6 carbons in the chain. It's a 3-hexene, 3-ethyl 4-methyl 3-hexene, or 3-ethyl 4-methyl hex 3-ene. This is how you name simple alkenes. But you can have molecules in which there are more than one double bonds, and for that you have to see, or you have to take into account certain other rules which we will discuss now in a couple of minutes time. The first rule is that you have to number the carbon atoms in the chain so as to give all the double bonds the lowest possible positions. And now you have to slightly modify the name as well. You know that we use prefixes but, pent, hex, hept, oct for the number of carbon atoms in the chain. But if we have more than one double bonds, these prefixes change and we add a to these names or these prefixes. So but becomes buta, pent becomes penta, hex becomes hexa. And then we add another prefix before ene, mentioning the number of double bonds present in the chain. So if we have two double bonds, we use the prefix di, so it becomes diene. If we have three double bonds, it becomes triene. If we have four double bonds, it becomes tetraene. So the prefix for the number of carbon atoms change, and we add another prefix for the number of double bonds before ene to mention the number of double bonds present in the chain. If all the double bonds they fall at the same positions from both ends, then obviously you have to take the position of the substituents into account for numbering the carbon atoms in the chain. Let's see some examples to understand this. So we have a simple example here. We have 4 carbon atoms in the chain and we have 2 double bonds. So for a 4 carbon chain, we use the prefix but, but again we have 2 double bonds here, so the prefix but becomes buta. And because we have 2 double bonds, So we add a prefix di before ines. So it becomes butadiene. And obviously, you have to mention the positions of the double bonds. So if you start from the left, the double bonds are at 1 and 3. If you start from the right, the double bonds are at 1 and 3. So it's a 1, 3 butadiene. Or you can write it as buta 1,3-diene. Here we have another example again with two double bonds, and now the chain is longer. We have 5 carbon atoms, and of course a methyl substituent is here. In this case, the number of the positions of the double bonds are different. From left, they are at 1 and 3. From right, they are at 2 and 4. So you start from the left so as to give lowest position to the double bonds. And so the name becomes 4-methyl, because at 4 we have a methyl group, pentadiene. And which pentadiene? Of course, you have to mention the position of the double bond. So it's a 1,3 pentadiene. Or you can write it as 4-methyl penta 1,3-diene. Then we have this molecule. We have 3 double bonds. So it's a triene. Count the number of carbon atoms: 1, 2, 3, 4, 5, and 6. And we have a methyl substituent as well. So it's a hexa triene. And if you look at the position of the double bonds, they are similar from both ends. And at position 2, we have a methyl substituents. So it becomes 2-methyl 1,3,5 hexa triene, or 2-methyl hexa 1,3,5 triene. You can write it in both ways. Finally, we have another triene here, and again, if you look at this chain here, it has 6 carbon atoms. Double bonds have the same positions from both ends, and so it cannot decide from where we should start numbering. Then you have to take into account the position of the substituents. From left hand side, they are at 3 and 4. From right hand side, again they are at 3 and 4. But we have two different substituents, an ethyl and a methyl substituent. So again, you have to take into account the alphabetical order, and in alphabetical order, ethyl comes first. So you start numbering from here so as to give lowest position to the ethyl substituent. So it is at 3 and methyl is at 4. While writing the name, again you have to mention ethyl first. So it's 3-ethyl, 4-methyl, 1,3,5 hexatriene, or 3-ethyl, 4-methyl hexa 1,3,5 triene. So in this way, you can name alkenes according to the IUPAC nomenclature. I hope it helps. Thank you so much for watching. Stay tuned for more lectures on nomenclature.